Now, in this video, we're going to be using the formula that is used to find the percentile rank. Now, it says here, the percentile rank for a given data point in a set of n total values can be calculated by using this formula. The percentile value of x equals to the number of values less than x divided by n, which is your sample size, times 100. Once you do that, you can find the percentile. Now, in some textbooks, they use this formula as we were going to be using in Stats 250. It will be the number of data values less than x plus 0.5 divided by n, which is the sample size, times 100. Now, why plus the 0.5? When we add the 0.5 here, we're using it to be more precise in our calculations, to get more of a precision. Can't even say that word. Precision. Anyways, so this is the formula that we'll be seeing in Stats 250. And because in Stats 250, we're diving in more into statistics. So we're looking at more precise percentiles. But for Math 108, we're going to be using this formula right here. And kind of the same approach that we did in the last question. So let me erase this. Well, actually, before you do that, if you want to, you can take it down. Okay, so we're not undoing it in this case. All right, let's erase. So it says here that the result should be rounded to the nearest whole number as well. The number of words in each of the last presidential inaugural addresses is listed below. For one thing, who has time to be even looking at this? Anyways, let me get off my high horse. Find the length that corresponds to the 30th percentile. Okay. So let's put the numbers in order first. So the smallest amount of words that I see here is going to be 1,433. So 1433. Then the next one that I see is going to be 1592. Then I see a 1598. Then I see a 2071. 2096. 2155. 2320. 2395. 2427 and 2561. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the values are in order. And if you look here, there are 10 presidential inaugural addresses. So 10 values. Now, I want to find the 30th percentile, correct? What value represents the 30th percentile? So I'm going to write this formula more in words, where P is equal to X divided by N times 100. In this case, X will represent the number of values less than the specified value. Okay. So I want to find the 30th percentile, right? So I can say that P equals to 30 because the percentile in this case is the 30th. N equals to 10 because there are 10 different presidential inaugural addresses that I see here. I can use this formula to find the value of X. And X will be the number of values that are less than the specified value. So P equals to X divided by 10, or rather in this case, my apologies, 30 equals to X divided by 10 times 100. Now we can divide 100 into 10 because 10 goes into 10 once and 10 goes into 100 10 times. So we can have 30 equals to 10 times X. To get 30 by itself, we're going to divide both sides by 10. That means X equals to 3. Now remember, X equals to the number of values that are lower than the specified value. There are 3 values that are lower than the specified value. There are 3 values lower than specified value. So going back to our data set, we want to see which value has exactly 3 values that are lower than itself. And that value is going to be 2071. Why 2071? Well, 2071 has these 3 values that are lower than that score. So the 30th percentile is going to be 2071 words. Now, if X was equal to like 5, then the value would be 2155 because X represents the number of values lower than the specified value. And there will be 5 values that are lower than 2155. That's why 2155 will be the 50th percentile. But in this case, because we want to find 3 values that are lower than the specified value, our percentile has to be 2071. Once again, because there's 3 values that are smaller than 2071. All right, guys, that is it. That is how we find a value that corresponds to the percentile. I'll see you soon.